Have you ever imagined what would happen if two planets collided? Would Earth survive a collision with Mars? In today's video, we will explore these incredible scenarios through realistic simulations that will leave your jaw dropping. If you are a fan of games and love to imagine the impossible, get ready to see how these catastrophic events would unfold in space. Stay with us until the end to discover the most surprising outcomes and understand how these collisions could transform our solar system. Let's dive into this cosmic journey together and unravel the mysteries of planetary collisions in a way you've never seen before. Before we dive into the simulations, let's quickly understand what planetary collisions are and why they are so significant in science. Planetary collisions are catastrophic events where planets or large celestial bodies crash into each other with tremendous force. These collisions have the power to shape the formation and evolution of planets, create new moons, and even influence the potential for life on other worlds. Such events are not just theoretical, they have played a crucial role in the history of our solar system. For instance, it's believed that the Moon was formed from the debris of a massive collision between Earth and a Mars-sized body named Theia. These collisions can also explain the peculiar tilts and orbits of some planets. Understanding these dynamics helps scientists gain insights into the past and future of our solar system. To bring these simulations to life, we use advanced modeling software that allows us to recreate the conditions of planetary collisions with incredible accuracy. These tools rely on real data and precise calculations to simulate the physical and chemical interactions that occur during such catastrophic events. In this video, we'll be using software like Universe Sandbox and other astrophysical simulation tools. These programs enable us to visualize the immense energy released during collisions, the formation of craters, and the resulting changes in planetary atmospheres and surfaces. By leveraging these technologies, we can provide a vivid and educational experience that helps us understand the possible outcomes of these dramatic cosmic events. Let's kick off with one of the most intriguing scenarios, a collision between Earth and Mars. What would happen if these two planets were on a collision course? In this simulation, we'll witness the dramatic impact and its immediate and long-term consequences for both planets. As the simulation begins, you'll see Earth and Mars hurtling towards each other. Upon impact, the collision generates an immense explosion, releasing energy equivalent to billions of nuclear bombs. Massive craters form on both planets, and the shock waves travel across their surfaces, causing widespread geological upheaval. For Earth, the consequences are dire. The collision would likely strip away a significant portion of its atmosphere, leading to drastic climate changes. Oceans might vaporize, and the surface would be covered in molten rock. For Mars, the impact would also be catastrophic, potentially shattering the planet and sending debris flying into space. This simulation helps us understand the sheer scale of destruction that such a collision would cause, highlighting the fragility of planetary systems and the powerful forces at play in our universe. Now, let's explore how different angles and speeds of collision can alter the outcomes. We'll simulate a variety of scenarios to see how these variables impact the results of planetary collisions. First, we'll look at a head-on collision. In this scenario, the planets collide directly, resulting in maximum energy release and destruction. The impact is so intense that it can completely obliterate smaller planets or significantly alter the larger ones, creating vast craters and ejecting massive amounts of debris into space. Next, we'll examine a glancing blow, where the planets collide at an oblique angle. This type of collision often results in less immediate destruction but can have significant long-term effects. The planets might exchange surface material, leading to changes in their compositions. The impact can also alter their orbits, potentially sending them on new trajectories that could affect other celestial bodies in the solar system. Finally, we'll simulate collisions at different speeds. Higher-speed collisions release more energy and cause more extensive damage, while slower collisions might result in less dramatic but still significant changes. These variations help us understand the complexity and diversity of outcomes that can arise from planetary collisions. By visualizing these different scenarios, we gain a deeper appreciation of how small changes in initial conditions can lead to vastly different results, underscoring the unpredictable nature of cosmic events. Planetary collisions don't just destroy, they also create. One of the fascinating outcomes of these cataclysmic events is the formation of new celestial bodies, such as moons and rings. In this section, we'll explore how the debris from collisions can coalesce to form these structures. Let's start by looking at how moons can form. When a massive collision occurs, the debris ejected into space can gradually clump together under the influence of gravity. Over time, these clumps can grow larger, eventually forming a new moon. This process is believed to have created our own moon, which formed from the debris of a collision between Earth and a Mars-sized body named Theia. Next, we'll examine the formation of planetary rings. In some cases, the debris from a collision may spread out and form a ring around the planet. These rings are composed of countless small particles that orbit the planet, creating a spectacular visual display. Saturn's rings are the most famous example, and they are thought to have formed from the remnants of a shattered moon or comet. Through our simulations, we can visualize these processes in action. You'll see how the debris from a collision gradually comes together to form moons or spreads out to create rings. These visualizations help us understand the dynamic and ever-changing nature of our solar system, where destruction and creation go hand in hand. Let's take a moment to reflect on what we've learned from these simulations. We've seen how catastrophic planetary collisions can be, not only in terms of destruction but also in their potential to create new celestial bodies. These events have shaped the history of our solar system and continue to influence its evolution. Understanding the dynamics of these collisions helps us appreciate the delicate balance that exists in our cosmic neighborhood. It's fascinating to see how small changes in variables like angle and speed can lead to vastly different outcomes. This unpredictability highlights the complexity of the universe and the powerful forces that govern it. Now, we want to hear from you. Which scenario did you find most intriguing? Do you have any other types of collisions you'd like us to simulate in future videos? Leave your thoughts and suggestions in the comments below. Your feedback helps us create more content that you enjoy and learn from. By engaging with these simulations, we not only satisfy our curiosity but also gain a deeper understanding of the universe. These visualizations make abstract concepts more tangible and highlight the importance of scientific exploration. So, keep questioning, keep exploring, and let's continue this journey together. Thank you for joining us on this incredible journey through the cosmos. We've explored some fascinating scenarios of planetary collisions and gained a deeper understanding of the powerful forces at play in our universe. From the dramatic impacts between Earth and Mars to the formation of moons and rings, these simulations have shown us the dynamic and ever-changing nature of our solar system. If you enjoyed this video, please give it a thumbs up and share it with your friends. Don't forget to subscribe to our channel and hit the notification bell so you never miss an update. We have plenty more exciting content lined up, and we can't wait to share it with you. Remember, the universe is full of mysteries waiting to be discovered. Stay curious, keep exploring, and join us next time as we dive into more amazing simulations and cosmic phenomena. Until then, keep looking up at the stars and wondering about the incredible events unfolding in the vast expanse of space.